Hey, hi everyone. Good morning. Welcome to the workshop 3 as part of the Kubernetes Community Days KCD Kerala 2024 event. As you see in the screen, this workshop is about how to deploy your application on Kubernetes. The title is Deploy Your Application at Scale in Kubernetes. Okay. This is going to be a hands-on workshop. That means we expect you to interact with Ginesh, who is the speaker, and then he will actually be doing a presentation plus semi demonstration, plus then help you by sharing the documentation on how to do the workshop steps yourself. Okay. A quick introduction about myself. My name is Srijit Anujan. I work for Red Hat. And then today we have Ginesh Madaparambat, who is our distinguished speaker for this workshop. Ginesh will actually be taking us through this presentation and the interactive discussion. Now, a quick word about Ginesh. Ginesh currently works for Red Hat as a consultant, mostly focusing on Red Hat's DevOps strategy, basically around our automation and containerization tooling, which is Ansible and OpenShift. Now, talking about Ansible, Ginesh actually released a book last year, which is Ansible for Real Life Automation. So, one of the popular books in the automation stream. So, check it out in Google and get a copy if you want. Ginesh is logged in from Singapore. So thank you so much, Ginesh, for supporting us with this event. I know it's lunchtime for you, but truly appreciate your support in this. With that, I'm actually handing it over to Ginesh. Over to you.
Thank you, Srijit. Thank you everyone for joining today. Uh, Let me know if any issue with audio or screen share. Uh, okay, okay. So I think good morning, good afternoon, everyone. So basically, this is a virtual hands-on session here. But I know maybe your environment is not ready, or maybe you're just preparing, or you can do it later also. Just follow the screen instructions, and I will share the documentation to how to practice whenever you have time or whenever you have an environment. Okay. Okay. So first of all, thanks to KCD team and all the community for giving me this opportunity. So we will try our best to present this in a interactive way. so So for today, we have a very small agenda. So we will see what is Kubernetes, not in detail, like what is a deployment, what is a replica set, few slides, and we will see what is actually why need scaling and how we can do the auto scaling and all those details. And of course, with the demo, it's not a demo, actually it's a workshop, sorry for that. And Q&A. So questions, we can keep it for the end actually. Just put in the chat so we can answer anytime, whenever we have time. So mostly yeah, please. Okay, hope that is not a question. Okay. So basically,
Ginesh, oh my God. Yeah, sorry for the, for the echo. Just wanted to keep you posted that, I will be watching over the questions. Okay, there's still some echo. Yeah, I will be watching over the questions and I would be interrupting you. And I would also request you to, keep asking the audience whether they are with you when you're following the steps, right? Because in the last workshop, we saw that couple of our guys were not able to follow and they were stuck at some point, right? So just keep checking with them whether, whether they are following you and whether they are at the right step with you, right? Just have it. And I will stop you in between if I see a question as well. Yeah, thank you.
sure. Thanks for that. Yeah, sure. Please. Okay, so the target audience basically beginners to Kubernetes, or if someone is already Kubernetes but not sure how to do the scaling, what is scaling and all. And takeaways, basically you will learn how you can do the scaling, the automated scaling based on some metrics like traffic or workload. So I think I can skip the slide because Srijit already helped to explain. So basically, I'm from Singapore, but basically I'm from India, work in Red Hat Singapore. Okay, so the first slide. So what is Kubernetes? We all know this is just for the formality. Okay, we are not going to discuss very detail about Kubernetes. What is Kubernetes? And all you already know, I believe. So basically, this is open source container platform available now, and this is one of the not one of the actually the most well-known open source container platform project at this time. You can basically automate most of your application deployment tasks, the scaling tasks, the automated remediation, automated workload management. Everything can be done using the Kubernetes. This is actually a container orchestration platform. Don't confuse with the Kubernetes, Docker, Podman thing. So Kubernetes is basically an orchestration platform. Remember that. Now, Kubernetes got a lot of components. We are not going to discuss a lot in detail here in this workshop. Basically, we have to learn what is pod. So pod is the smallest unit in Kubernetes. So it represents exactly a simple instance of a running application. Like it can be a web server, it can be a database, it can be any application server. It will be running inside a pod, but inside the pod, what is it? It's actually a container. So pod is like a kind of you have an extra layer on top of container. Kubernetes always deal with the pod, not directly deal with the container. So you have this kind of technology inside. So pods are used to deploy like can be any application. So most of the time you will see when you deploy the application, it's deployed as a pod. But on the system, you can still see the actual containers managed by the container engines, like you manage the Docker or Podman containers. But we are not going to test this container manually here because everything will be orchestrated by Kubernetes. Now, we have to learn or we have to understand what is a different type of deployment or different methods available to deploy our application. So basically, we are not going to deploy a pod as it is because we can deploy, but that's not the actual way of deploying. So we can deploy is like a deployment is an object. So we can manage the deployment using the deployment, and you can scale it like one pod, two pod, or three pods like that. So you just visualize the virtual machine here. So virtual machine, you have one virtual machine. Then when you have workload, what you will do? You will increase the virtual machines, number of virtual machines, then make it like a load balancing between one or more virtual machines. Here, the pods are doing the same thing, but we are using deployment. So deployment will handle the internal number of pods automatically using the Kubernetes mechanism. The good thing is deployment will allow the rolling updates and also the rollback. So a rolling update is basically when you have a new version of the updates. When you have to update the application, you don't need to switch it from A to B without, you can switch it from A to B without a downtime. So this is a rolling update, and we are not going to discuss. We don't have a time for that. If any question, please let me know. Then we have a replica set. So replica set ensure the specified or desired number of replicas of a pod are running. So for example, if you define, okay, I need 5 pods of this application running in a Kubernetes cluster. So replica set will help on that part. Then we have a replication controller. Basically, this legacy or old concept. Nowadays, we are not using, I guess, and mostly replaced by replica set or deployment. So just understand the difference. There are different mechanisms available in Kubernetes to deploy your application. Okay. Now, this is another thing you need to understand. So you can deploy any application or create any resource in Kubernetes in 2 methods. One is the imperative or the command line method or the pure commands. You use the kubectl and run, and you pass these parameters like image, other arguments in the command line, like the lengthy commands. But it's not possible to execute or create resources or manage Kubernetes resources in this way all the time, because you have to remember all these parameters. The chances for error, sometimes we miss some arguments or typos will be there, and the main issue is if you want to recreate, you have to copy paste or you have to remember all these parameters again. That's why we always use the declarative method, where you keep all your Kubernetes declarations or the resource declarations inside a YAML file, like you can see on the right side. So you define all the parameters required, like what is the resource is a pod, then you can put the metadata like a name, then you can put the project or namespace, then you can mention all the specifications inside the YAML, then you apply these configurations. Most of the time you will be using the declarative method. So whenever you have CI/CD kind of thing, or you have automated pipelines and you have automated deployment, then mostly we will be using deployment using YAML, not the CLI one or the imperative one. But imperative one is very good when you want to troubleshoot something. Let's say you want to test something, you found, okay, something wrong with your YAML, then you want to test it again and again. It's not convenient to edit the YAML, apply again, edit the YAML and apply again. That's not the right way. So you can do the imperative method, and it's fast for troubleshooting and all. Okay, now the main topic here, why you need to scale the application. So basically, just remember, just visualize. Okay, you have a, like, I don't know what you call the Black Friday's sale, or something like a 11/11 sale or 12/12 sale, whatever we call in our country. So whenever you have a sale in Amazon or Flipkart or Shopee or Lazada, what will happen on that day or before that day or after that, during that period, you are expecting some heavy traffic, because there is a promotion happening and you are expecting a heavy traffic. So by default, okay, mostly users are logging like 1 million users, okay, but that day there might be 10 million users, we don't know. So we have to plan this workload, and you can do this planned scaling. So increase the number of pods or number of workload, number of application capacity, just to handle this traffic. But what if we cannot plan this in advance? Let's say we say, okay, this will be only 10 million, but we can see there might be like a 20 million traffic. Then the application will crash. It happened many times. You can see, if you remember all websites, whenever you have the ticketing system or any kind of system, your application will crash, or the website will not be available like that. So you need a plan for the automated scaling. Now, whenever we talk about the scaling, there are two scaling we have to understand. One is the vertical scaling, because when you have an application which require like a 32 MB memory or like a 42 MB memory, then you can increase the application pod capacity to 64 MB or higher one. This is kind of a vertical scaling, but this is not really recommended. You can do that, depends on your application type and all. But mostly we are talking about the horizontal scaling here, and we have a resource called HPA, horizontal pod autoscaler. So in horizontal scaling is like virtual machine one we discussed earlier. So we have one instance of a application. Then you can create multiple instances of the same pod, and to ensure like, okay, the more workload will be handled without any issues. So if you check the right side, we have one pod with 32 MB, but whenever there is a traffic or more request is coming, then you can increase the number of pods, not the capacity or not the memory value. Okay, understand this. Don't confuse with the vertical scaling and horizontal scaling. Mostly we will be talking about horizontal scaling here. Now, how do we know the traffic? Because we know, okay, there is a promotion happening, then kind of thing, then that's a planned one. But unplanned one, how do we know, okay, whether there is a traffic is coming tomorrow or next 1 hour? That's where we can use the metrics. So metrics is like the details about the resource, like CPU resource, memory resource, all those things we will be observing, like what is the current memory usage, what is the current CPU usage, what is the current network or disk usage. I think you will be doing this in the virtual machine, all those cloud environment, but in Kubernetes, we have a metric server available. You can go with the native metric server or the additional third-party metric server, whichever you want to use. Basically, for this workshop, we will be using our metric server, and we are checking the pod, memory, and CPU usage. And based on the traffic, we will try to scale up or scale down the application deployment. Okay. Now, auto scaling, how it works? Basically, you have a n number of ports at this time based on some traffic. Then you have a matrix running on the time, which will gather all the information about the CPU, memory, all the other workloads usage. Then the HPA or our horizontal port autoscaler will be observing these, and based on the value and based on your configuration, it will increase or decrease the number of ports. That's a very basic one. Whenever the traffic is like lower, like it's going down. Okay, you found the promotion is over. You don't need to keep these kind of ports or this kind of application system at this time. So what you have to do, scale down. So you can scale down, but this is also automatic. So based on the metrics, there will be cooling down period. Actually, you cannot just simply cool down to from 10 nodes to 4 nodes in the next 1 minute. So there will be cooling down period. You can configure that. So once period is over, if no more traffic is coming, it will remove or destroy the ports, and it will keep only the minimum number of ports based on the traffic. Yes, yeah, that's correct. So you can do the same for nodes, because the auto scaling of nodes, but we are not going to discuss that in section, maybe some another session. So in this one, we are calling about ports. Remember that. That's it for slides. Actually, I don't have my slides for that. We will switch to the demo screen. Okay, let me know if you can see my screen and if it's readable. Is it readable? You want to increase the font?
Yeah, it is readable.
Okay, great. Okay, thank you. So what we are going to do is very simple. So we have some prepared.
Can you just make it a little bit more bigger?
Sure, please. Sure. Is it okay now?
Yeah, it's better. Yeah, better.
Okay, sure. So basically, what we are going to do, we have prepared some YAML files for the deployment, just for the demonstration purpose. So we are not going to prepare it from scratch. So if you want to try with any other deployment, please follow these deployment YAMLs, and you can just replace the values and try with any other application. Please try that. Okay. Now, first thing, we have to check the Kubernetes cluster here. So basically, I have a Minikube running here. You can use any Kubernetes cluster. It can be Minikube one, it can be kind local development environment, it can be a real Kubernetes cluster with a multi-node, or you can use the actual EKS or any cluster. Okay, doesn't matter. It's just it should be a Kubernetes cluster. Okay. So I have a Minikube running here, and we will be using this Minikube for the workshop. If you are try in parallel, you can try it. Let me know if any questions, or let anyone in the call if you have any issue with any commands or something. Okay. Okay. So basically, the repo is already available. It's a public. You can access this, which will actually create deployment based on the Nginx. Then we have one with a to-do app, and we have another one with a WordPress. Okay. So just to demonstrate, we'll try to see, I mean, what are the shows we can do. First, we will try with the basic Nginx one. Okay. Sorry for that. So the first one, we are trying to create a simple Nginx application, and we will test how we can scale based on the metrics or based on the load. For load, we can use any kind of load testing tools, but we will be using Hey here. There's a small tool actually. You can use any tools, it doesn't matter. Now, we don't have this application deployed here.
Yes. Can I stop you for a second?
Yeah, please.
I just wanted to check with the audience if they are able to follow the steps that's been given. Right. So first thing is that you need to now access your Kubernetes cluster. And Agnish, can you just share that, I mean, that link once again on the chat, because maybe there are like few people joined a bit late. So can
Yeah,
you
sure.
just, yeah,
Pasted.
yeah, just 1 second, Ganesh, 1 second. Yeah.
Yeah, sure.
Yeah, so Ganesh, so the first step that you're talking about is to get access to the to your Kubernetes cluster, right? So that
Correct.
is, yeah, so that is what you want. The audience should also be doing that, right? I mean, get access to the Kubernetes cluster.
Yeah,
And
that's correct.
is there any particular YAML file that they should run, or I mean, is that something which you would tell them, which
Yeah,
YAML?
so correct. So I will go to that repository now. So basically, you make sure you have a Kubernetes server, sorry, Kubernetes cluster ready. You can access it. You should be able to see the kube system or the ports or other ports if you have any. Then we will be deploying it. So once you have this, the next thing is you have to access the repository. Actually, the link is already there in the workshop instruction. Let me know if you can see that.
Girish, can you also move between your terminal as well as the can you also open that link and share
Yeah,
that? Yeah.
correct. I'm opening now. Okay, so basically maybe I can open this workshop instruction here. It will be easy for you. Okay. So basically this is a workshop instruction. If you check, we have different number of exercises from starting with a small Nginx, and we will do some tutorial WordPress side. For the prerequisite, I mentioned we need a Kubernetes cluster running. Then we should have a kubectl installed and configured so that we can access the cluster and do these kind of exercises. Then access to the demo repository. This is the demo repository. So here there are basically three YAML files, and you can just copy from here or just clone the repository and do this. So the first one is nginx.yaml we are talking about, and I have already cloned that repository in my system, and this is the file here. So these are workshop demos, and this is the file we are talking about. Let me make it more bigger. I will explain this YAML if you are ready. So just make sure you have a Kubernetes cluster working. If you want to do it later, it's fine, but try to follow this if you can. Okay, I assume no other questions for now. So let me explain this YAML. It's not that complicated. Basically, we are creating a namespace. Usually, it's a best practice to create the namespace for different applications. You don't want to create the applications and deploy inside the default namespace. That's not the right way. So in our application, what we are going to do, we create a namespace. Then we will create a deployment. Inside the deployment, you can see we are creating a deployment called Nginx deployment. And we already mentioned, okay, it should be created inside the namespace called web app. It can be anything. We are just using a web app name. It can be Nginx, it can be anything. Then replicas, I mentioned only one. Okay, just one, the default one. Then you have some labels. This is mandatory actually. You're creating a label nginx-web so that you can configure it many places. Then you create one container here for Nginx. Using the Nginx latest image, you can replace with any other image if you want. Then default port is 80. You know this already. And you have to, this is the main step. Don't miss this one. Because if you want to know whether the traffic is good or is okay or more, you should know, okay, what is the current capacity of the pod. So we have to mention the request and the limit. So request is something, the default value. I mean, you are telling the Kubernetes to reserve or provision like 256 MB of memory and 250 micro, okay, CPU, not micro, sorry, milli, CPU value. Then you also mentioned the same for limits. You're like, okay, this is the default value, but it should not use more than limit value. So you have to mention this very clearly inside your deployment. Otherwise, you don't know how much resource the pod will take. This is very, very important. I will show you something here. If you are using a good IDE, your IDE will show you some error here based on the value because it says, uh, so yeah, we are referring to the YAML files here. Actually, I mentioned that inside. Let me check if I missed. Uh, I think there is a formatting issue, but yeah, actually I mentioned that here, cloning the repo here. Hope it's accessible. Let me know if otherwise. So when you don't mention the resources, what will happen? It will show you some error. If you are using a good IDE with linting and all the YAML linting enabled, it says, okay, one or more containers do not have the resource limits. This could start other process. Means you are not telling the Kubernetes how much memory, CPU, or the resource value or limit is required for this. And this is mandatory. Okay, always remember that. This is a good thing with our IDEs. So this is a VS Code, and I have some Kubernetes plugins installed. So it will tell me like, okay, the YAML is good or following the correct practice or not, everything. Okay, that's good. So we have the engineers YAML with the deployment. Now we have some more information inside. So this is called services. So we are creating a service object, and we have already given a name called Nginx Node Pod Service. It can be anything. I'm just creating a Node Pod service here because I'm using a Minikube. We should be able to access directly using the Node Pod. You can use the other ingress, all those things, but this is just for the workshop. Okay. Then the selector, this is important. You can see here the selector. I have used an app label here, the same label here. So remember to replace these when you are using this YAML and editing this for any other application. Okay, when you copy, if it's not working, just make sure, okay, you're following the right labels or selectors. And the port, I'm using 8080 for exposing, but internally we know the target port is 80. That's the default port for Nginx. Any question on the YAML file, let me know. Okay, great. Thanks for that. Now what we are going to do, we will just apply this. You can still use the default. I will follow this. Okay, you can still use the default method like kubectl organ and all, but for the workshop, I mean, just to make it easy, we are going to apply this directly, the YAML file. Okay. So the Kubernetes will create a namespace. It will create a deployment, and it will also create a service. So we can see something like this: kubectl get all web app. The commands are already available in the same workshop instruction page. So you can see, okay, there is a pod running. There is a service already created with a type of node pod. And there is a deployment created, and desired state is one, available one. And we can see the replica set, which is not created by our YAML. It's created in the backend by Kubernetes for the deployment. Okay, remember that. And it says desired state is one, current is one, ready is one, all good. Now, the main thing, we forgot to check uh, the metrics because we have to ensure the metrics is already available. So what we have to do, we have to go back here. If you follow this metrics part, sorry for that, I missed when we have a kind of a talk, we have to enable the metric server. If you are using any other Kubernetes cluster, not the Minikube, you follow the right method for that. In our Kubernetes, it's very easy. You just need to add Minikube add-ons and enable the metric server. You can do it anytime. It will just deploy a pod, another pod. You can see it here. It will be running like this. So in our case, what we are going to do, so there is a metric server running under kube-system namespace. It's good. So we can use that metric now. Okay. So first thing, we have to ensure the metric is good. Otherwise, the auto scaling will not work because nobody will tell the horizontal autoscaler that, okay, there is a heavy traffic or there is a high usage of CPU or memory. Okay. Now, what we are going to do, we have to expose it. So the expose, you can use the command kubectl expose and deployment or the pod, but in our case, we have already created the service. This is just an alternative method if you want to do some hands-on. Now, the important one is to ensure, okay, our application is running or not. So in our case, this is a not pod type service. What we can do, we can just use the minikube service --- URL command to see the actual pod, not pod exposed by the minikube. We didn't mention anything inside our YAML. You can mention here, like a specific node pod. You can optionally mention, okay, I always need this pod for my application. You can do that. But in our case, we just commented out so that the minikube can just send some specific node pod, whatever available. Okay. So we use this command minikube service URL and we mentioned the service name. So this is the service name here. I've explained that in the documentation. This is the service name. So here we mentioned the service name. Then this is the namespace. So minikube says, okay, this is the pod and this is the minikube VM IP address. Now I can access my application here. So this is just a very basic Nginx file. The web page is very simple, the default one. We don't want to change it now. Okay. Anyone got question or something wrong with the commands or any issue, any blocker? Great. Okay, that's good. So this is something very basic one. So we have deployed one application and we are able to access the application all good. Now, you can also check from the CLI, but yeah, whenever you have browser access, it's very good. Now the scaling part. We are scaling the application manually. So what we will do here, on another console here, I want to watch the kubectl chat all. So I'm just watching, okay, how many number of ports we have now. Okay, so this is another console. I can see only one port running. So what we are going to do is we are going to manually scale it. Okay, there is a promotion happening in the next 1 hour. So we have to ensure the application can handle that kind of traffic. So when you do that, what do you have to do? kubectl scale deployment. We are scaling the deployment, not the pods. We are talking to the deployment, the replica set, everything will happen later. kubectl scale deployment. Then what is our deployment name? Nginx web server or Nginx, I think Nginx deployment. So we can check this. Yes, Nginx deployment. And always mention our namespace. Now the main part, you have to mention the number of replicas. Okay, I'm expecting some 3 times more users. So I'm just increasing the traffic with 3 ports. So what will happen? You can see on the top, automatically Kubernetes is making some adjustments in the backend. The deployment already you can see it's 3, up to date is 3, available 3. Replica set also says decide is 3, current is 3, and ready also 3. And we can see 3 pods running. This is good, but we don't know in the next 1 hour there will be more traffic or not. In that case, what you have to do? You have to follow the horizontal pod auto scaling feature in Kubernetes. So I will put it back to 1, wait for the termination. So Kubernetes already made some adjustment. Now we have only 1 pod running. This is good. Now for creating the horizontal pod autoscaler, what you have to do? You have another command, or you can also use the YAML. So in our case, we are just creating the HPA using our command. Let me explain this. So basically, you have a command called kubectl autoscale. Then you are again talking about the deployment. And then you mention the deployment. Then you can also mention the HPA name, many other configurations. But for now, we are just using the CLI here to explain and for you to learn. So here we are telling, okay, if the CPU percentage is more than 80% increase, or based on if it's less than 80% decrease the number of ports. So it's kind of an adjustment. You have to mention this minimum number of ports. You need minimum 1 and maximum. So even the traffic is 1 million, you cannot handle because your cluster may not have the capacity to handle that. So you are telling, okay, maximum 5 ports. So what will happen? Kubernetes will create another object called horizontal pod autoscaler, and it will observe the metrics. But in our case, we don't have any traffic yet. It's all good, nothing to do. Now we are simulating the traffic using some application. So for that, there are many tools actually, but in our case, we are using the it's a tool. You can use any other tools available. It can be advanced or it can be simple, anything. But in our case, we just want a simple tool to increase the application load. So here we are just asking the tool to run it for 4 minutes continuously to sustain a load, like so many number of connections. Then the number of connections, I say, okay, 15. I need a maximum of 15. And I also need to mention the targets server. It can be google.com, it can be facebook.com, but in our case, it's our Nginx server. Okay. We will copy this here. And we have to mention the port. So our port was 30689. Remember this. Now, what will happen? The tool will simulate the heavy workload, and it will try with many number of connections in parallel to increase or simulate the workload. So the Kubernetes will be like, okay, there is a more workload. I need to talk to the horizontal pod autoscaler and do something to increase the port capacity so that more application requests or more traffic can be handled. Okay. We can also check um, the metrics here. I think we missed to add that one. Let me add that here. Where is it? Oh, sorry, here. So what we'll do, we will watch some more items, watch kubectl get all, but we will also get maybe for SVC deployment. We will also watch kubectl top ports minus. Okay, so we want to see what is happening in the backend. So kubectl top ports is a command. Sorry for that. To see the current CPU and memory usage, you can see the node usage as well, kubectl top nodes. It will show you the memory, CPU, capacity, and usage of your Kubernetes nodes. Okay, so here we want to see the pod usage. We are not talking about the cluster capacity. Let us run this. So we can see, okay, the number of pods here, the service is here, deployment is here, all good. And this is the memory and CPU consumption. Okay, now what we are going to do, now the tool or the simulator will try to connect the server with 15 parallel connections for like a continuous 4 minutes, so that the CPU and memory usage will be increased. It's like more users are connecting now, and there should be some kind of heavy traffic to our web server. Let's wait for that. It won't be very quick one. It will take few seconds, then you will see some changes here. You can try that in parallel. You don't need to wait. You can check. Still the server is working, all good. Okay, sorry for, I think I did a mistake. You have to install this. I will give some time for that. That's my mistake, sorry. You can just simply download this from the here repository, or just download it from here. It's a bin file. You just need to download and just the path. If you have any other tool for the load checking, you can use that. I'm supposed to put it here. I will change it here. Sorry. Okay, we'll come back here. Now we can see there is a load and the CPU, the memory, all those ports already. We can see more traffic is there, and it will automatically create more number of ports based on the traffic. And we mentioned that, okay, it should be run for like 4 minutes continuously. You need more time to deploy this, let me know. Just download and set it. So if you are using Linux, this one for Windows and Mac also, you have a file available. You just need to make it like executable and use it. Okay, we can see the load is more again. So it will create more containers, but we have already mentioned that maximum is 5. So it will create maximum of 5 pods. And we can also see the workload on different ports. So you can see the application is running. We don't know, it's serving from different ports. If you put some kind of a custom web page with the host IP, you will see the different IP address here. Anyone, any issue or question with the load testing? Let me know, because this is the only way we can test it. If you have any other tools, benchmarking tools or stress test tools, you can use that, not an issue. Okay, so the test already completed. It will create like a maximum of 5 ports because we configured in that way. And you can also see the result here for the testing. So this is not an important. You can just skip this one. Important is this. Now 5 pods are running, but our traffic already go down, right? We don't have any more traffic. Okay, we don't have any more traffic means we cannot um, scale. Or you can automatically scale down after the cooling period, or you can make it like you can just update the replica to 1 because you know the traffic, the promotion is already done. No more sales or no more traffic will happen in that kind of way. Another way is to you can check this. You will check this kubectl get HPA or horizontal pod autoscaler. So this is the one we have created. So you can see the target here, all the details, minimum, maximum, but it's not going down, right? Because if you check the command, okay, you can use like kubectl get HPA web app and -o YAML is for getting the results in a YAML format. And also we are piping with a less so that I can go through the YAML easily. Now, you check the HPA resource here, what you can see? Maximum replicas, 5, minimum 1. Yeah, that's what we configured. Resource is purely based on the CPU, not based on the memory. So if the CPU resource is more than 80, it will go by. Why it's not going down? Because you didn't configure the cooling down period. So cooling down period is usually, I think I forget actually 300 seconds, if I'm not mistaken, almost 5 minutes. After 5 minutes, if not much traffic, it will slowly bring down the pods. Then you will see 1 or 2 pods only. Okay, you can configure that, but we didn't configure any such advanced level stuff inside. You can just check the HPA configuration and explore with that. So this is very basic Nginx anyone can do, so not a big deal. So what we are going to do, we will try with some simple application. Okay. So for the application, what we have to do, I have a very small Minikube cluster. I will destroy it. So there is a step or housekeeping because we know this is just for testing purpose. We don't need to keep it every time. So I can always delete. If I want to delete all these things, there are many things, right? So if you check here, kubectl kubectl get all minus n web app. So we have ports, we have services, we have deployment, we have everything. But I can simply delete the namespace, or I can just do like kubectl delete, and I'm telling okay whatever defined in the deployment means sorry in the nginx file need to delete. Okay, just deleting all the resources, just cleaning up because we are going to try another exercise with the to-do app. Any questions, please let me know before. This is very simple one. I don't want to focus on the application this time. So the application is very simple, Nginx web server, nothing changed, nothing customized, because we focused only on the pod or auto scaling part. All good? Let me know. All good. Thank you. Thank you for that. So what we will do, we will try with a simple to-do app now. So we have a to-do app YAML here. Let me try to explain here. So sorry for the multi-window arrangement. This is just for like make sure you can see items in parallel instead of switching between the screen. Okay, for the to-do app, we have similar setup. We have a namespace called to-do, then we have a deployment, then we have a selector labels, then we have a simple to-do application. It's very simple one, no database. But remember this, we are exposing the pod, we are exposing the container pod on 3000. And we also mentioned some resource requests and also limits, because if you want to adjust the auto scaling, you have to put this value. Then we are exposing the service on 8081. Basically, it will expose to node pod, any random one, or you can mention something here. Okay, similar YAML, nothing has changed. just want to show some application, whether the application will work or not. So kubectl minus f apply, sorry, apply minus f to do app.yaml. So it will create all these resources based on the YAML configuration. So what we will do, we have to watch these items here to do. So we are watching the pods, services, and deployment. You can watch, get all and do it. It's just for you, just for demonstrating how it works in the backend. Then we are also watching the pod usage under the to-do app namespace. So basically, it's very simple. One application, one service, one deployment, all good, and the usage is very, very low. But we have some memory usage already, but we will see how. The first thing, we have to get the service details. So it's using the node port. What we will do, we need cube, and we have to use, sorry, the service command. It's the easy one. So the application service name is to do app. Sorry for that. To do app, and namespace is to do. So we ask Minikube to provide the node port IP address and the port. So Minikube says, okay, this is the URL you can use on the local host machine to access the application. Okay, this is a simple one. So I can add my items here like rice or something, whatever it is. It's a simple application, no database running. It's all storing the details inside the same port. But you can always connect it with a database, so it will be point to one database and all. So this is just to make sure, okay, application can be deployed and scaled using the auto scaling. Now, we will do the same procedure here. So we have to increase the traffic. So what you have to do, we'll call the hey and tell, okay, 30920. We are going to increase the workload, but you can adjust the values actually. So based on the application type, you will know, okay, how much memory and CPU is required in the minimum level. So based on that, you can increase or decrease this kind of testing. So for the to-do app, we will try with a similar values and see whether it's working or not. Anyone, any question? I cannot see much questions in the chat. Hope it's okay. If anything not clear or you want to explain, let me know. Thank you. So we are just pressuring, I mean, we are giving more pressure to the application using our pressure tool, and we will see what will happen. Now, I am purposely did this. I think nobody highlighted also. We don't have HPA here. So what will happen? The pod will be crashed because you didn't tell the Kubernetes to automatically scale based on the CPU or memory value. So you missed to create the HPA. Okay. I'm not sure everyone listening, hopefully check that. So we have to create the HPA before you pressurize it. So now nothing will happen. It will just increase the pressure. That's it. What we will do, we have to create the HPA for our to-do app like this. So we will use a similar values. You can create a maximum number of ports to 50 or maybe let's say 10. Adjust this and explore. CPU handling, okay, whenever it's more than 70%, because my organization says, okay, if it's more than 70%, please spin up another pod. And I spin up. So what will happen? It will create another HPA, get HPA, and based on the value, you can see, okay, it's maximum 10 ports, minimum 1 port, and based on the average CPU, 70%. Now we will call the K again. So we will see what will happen in the backend. So the CPU usage is already high because we mentioned the CPU, all the things here. Because of that, HP also created and HP already started working here. So you can see the multiple ports already created soon after we create the HPA based on the workload. But the head is putting more pressure. It will create more ports based on our configuration. We will just wait and see. Uh, Disable, sure. May I, there's a question, I guess. Yeah, please. Yes, you can. You can mention all the HPA details in the deployment. Let me see if I have some sample. Yeah, I have some sample in our next exercise. This one I just made it like a imperative command, just to show okay how it will work. Because when you create all together, you will not know okay what is happening. So we just do like a step by step. Of course, you have to create HPA in parallel as part of your yeah. Thank you. Yeah, sure. So yeah, some sample is available. You can also put the CPU value or memory value. You can configure everything here. Yeah, YAML actually when you apply the YAMLs, basically it can be multiple YAML files, and you can put like a kubectl apply -f start YAML or something like that. Or you can put like a separate YAML file. I'm just creating only one file with the multiple. You can see the start of every. This is the start of the one resource, right? You can keep everything in one file or separate file. Doesn't matter. Same effort. If you want to manage it separately, you can keep it. There is no harm. Yes, can. Okay, this is good. So we can see the ports are increasing based on the traffic, and yeah, that's it. The application still there, even with the pressure, nothing happened. You can still access the application, no issues. This is a good thing. So even with mega sales, you can do this kind of auto scaling for the application. Just want to show. Okay, that's good. Hope this is clear. If any question, please ask. Otherwise, I think we still have time for testing the WordPress app. If no other questions, anything, let me know if you have any issue to follow the instruction here or something missing. If some commands are used here but not mentioned in the page, let me know. I will update the page. No, to do app is using local one, so it won't. That's why I mentioned no database. So this is just to show the application. So assume okay, this to do app is just like some simple one, similar. So if another user is getting service from different port, you won't see this content there. That's where we will be using a database in the backend for the next. Okay. Let me, yeah, to do app, actually you can connect to database, but in this is a very simple one. We are not doing that. Okay, so to do app is good. We can see it's not just engineers. You can deploy any application and do the auto scaling based on the traffic or based on the memory scale. So based on your Kubernetes cluster, you can put like, okay, thousand or kind of pods and the requirement. So this is like a very like on-demand pod spin up, and it will help you a lot if there is a heavy traffic or heavy workload. So what you have to do? kubectl delete F to do app. Okay, that's gone. We don't have resource now. So the last one is our WordPress. So what happened in WordPress? So WordPress is, this is not a single application. So we create one namespace. So we have to create the persistent volume. So the PV or persistent volume will be created based on our PVC or persistent volume claim. So we have to create two PVC here, one for our database and one for our WordPress storage, because we are going to use one storage and different WordPress pods will be utilizing the storage. So you don't need to, this is the place where you create or delete pod every time you are getting the same result, because you are using the same data or WordPress files, and also you are using the same database. Okay, ignore these items. I was testing something, then I forgot to clean up. Ignore this. Don't confuse it. These are some of the scripts. If you want to do some startup scripts on the WordPress pods, you can do that, but this is not fully tested. Just ignore for now. So basically, you're creating one PVC for WordPress, another PVC for SQL, MySQL, and we are using the local storage portion. So what you have to do is, before that, actually, I'm not sure the WordPress are running. kubectl delete minus f WordPress. Oh, those running. It's okay. I will clear up already. You have to ensure you have a local storage person. If you are using the mini cube, actually you can use the local one. So kubectl get, sorry, storage. You can see a standard storage, and also you can see some default configurations. So if you are using any other cluster, and if you have any other storage configurations, remember to check if they support the read write many kind of access modes. Okay, because WordPress you have to I want to I want my WordPress different WordPress ports to access and adjust the configurations uh, regardless of, okay, which port. Okay, there is no master port, there is no client port, it's all like the same port. So we have a PVC for, now we don't have any PV. You can simply kubectl get PV. So these are the PVCs created. Let me delete this. Because I kept it like reclaimed. Let me, no more PVs. Everything clean. kubectl get PVC minus A. No volume claim as well. Okay, so once we create the claim, so it will automatically create a PV for us. I'll show that. Now we are deploying the WordPress application. So you can see we have a WordPress deployment, and we are using the WordPress laser. You can mention any version actually. We are using the WordPress default image. You can also mention the full path if you are using a different image or different container registry. Then I use some port default is 80, then mandatory one. Then this is important one. Here we have to tell WordPress what is the default DB host or the DB server, user, and password. Ignore this for now. This is something advanced. We don't need to work on that one. So we are passing some information to our WordPress deployment. We are saying, okay, DB host is WordPress hyphen MySQL. We will talk about that after this. Username and password for the database, because WordPress need to access the database and store something. Now we scroll down. We have a volume mount here for storing our WordPress web or PHP files. Ignore the second one for now. I will do the cleanup later. Now we have another deployment where we are deploying a MySQL pod with some specific version. You can use latest or something, depends on the WordPress support. Then I am telling some environment variable here. One is the root password. You are not supposed to use it as it is. You have to keep this password and all inside our secret config kind of, but just for the workshop, like a simplicity, I am just putting it in a plain text file. So we are passing the WordPress username, WordPress password, root password, everything here. So make sure it matches here. Okay. Do not mix up. Now we have also mounting a volume, which is actually the PVC name, WordPress PVC. And now the important one, right? When you say WordPress, you already mentioned WordPress host name as WordPress MySQL. If you check here, I have created a service object, a resource here inside the same WordPress namespace to talk to the MySQL, because we cannot use the IP address. We know we cannot use the pod IP address. And what we are doing is we create a service object with the WordPress -MySQL as name and mention that in our deployment. So WordPress know, okay, this is the service IP I need to use and talk to the database. Okay. Now we create two service. One is for the backend MySQL, and we have to create another service for the WordPress application. So we are exposing this port here as not port on a different port just for testing, and target port we know is 80 inside the container. And that's it. HPA we are not going to create using YAML because we want to see how it's auto scaling. If any question on the YAML, let me know. If it's not clear or some parameters are not clear, let me know. It's a very simple one. It's not complicated one. Where in the actual deployment, there will be more than more like hundreds of additional configurations because you are not going to use the password like these because you will be accessing the secrets. We don't want to go in that kind of a difficult discussion. Okay, so what we will do, we will start monitoring the pods first. So we'll use the same command, but this time we will observe our WordPress namespace. Okay, there is no namespace and nothing there. So kubectl apply or create -f WordPress or YAML. So now WordPress is creating a few items. Metrics is not available yet because the pod is just creating. So we have to wait for that. Basically, it will create a namespace, two PVCs, config map, ignore that, two deployments, two services. Okay, it's a two-tier application. So you have a application, actually it's a two-tier or three-tier, you can call it anything like that. So you have a web server, you have a PHP thing, then you have a backend MySQL. Okay, it says it's running. Wait for that. Hopefully it will work. WordPress is still creating. That's so in parallel, we can check the kubectl get PVC -n WordPress. So we can see two PVCs or present volume claims are created in the WordPress. Now we have to check whether the actual storage is created or not. The pod is running means it's already created. If the PVC is not PV is not created, you will not see the pod running. Okay, that's a kind of a prerequisite. We'll get PV. PV is the global one. So you can see there are two PVCs. One PV is PVC. PV is for WordPress MySQL PVC. another one for WordPress PVC. So we have two PVCs created and bound already. I mean, it's already connected. All good. Now we can see the ports are running. Everything good. Not for cluster IP. Here we don't need to access from outside, but the WordPress we need to access from outside. And the deployment is there. Everything good. So you can check here in the WordPress deployment. Deployment YAML. We have mentioned the request and limits. So you can see the average CPU memory value used by the WordPress deployment. Nothing much because nobody is accessing. So what we will do, minikube, service IP, then we know the service name here, WordPress app, -n WordPress. So minikube says, okay, this is the IP address to access the WordPress. So by default, WordPress will ask you for configuring the language, database, or all those things, but you can automate it, of course, or you can hard code it inside in any way. So in our case, we are not going in that kind of complicated steps. In the actual case, there won't be any initial application because you want the applications to be running as like it's okay, ready to serve. Okay, error establishing database connection. That's a good error. So what happened is from WordPress to MySQL, there is something wrong. I don't know. It was working. Sorry. Let me try to. We'll say this is like troubleshooting. Okay, something wrong with the YAML for sure. Maybe I made some mistakes. So what you have to do is kubectl get PO WordPress. Oh, sorry. Mm. Okay. Maybe my YAML got issue something somewhere. Let me check.
Yeah, did you provide the right service name with the WordPress app to connect to
Yes,
this?
actually, let me. So this is our WordPress service. Maybe I don't know. I missed anything. It was working. Then I think I modified something last minute. Yes, it's there.
WordPress MySQL. Okay. Can you just log into the the WordPress app pod and just see if you can access that host?
Yeah, let me try that one. Port um, PID is good.
I meant that you log into to the WordPress app.
Yeah. Mhm. Oops, sorry. I have it. Okay, where's my cursor? Okay, wait. Uh, there is an error I know. Ayo, what did I do wrong? MySQL. Sorry for that. I have some after
Okay.
this coding.
And meeting ഇങ്ങനെയാണോ വരുന്നത്?
Just can you mute, please?
ഇവിടെ വെച്ചാണ് അപ്പൊ
Yes.
വന്നുകൊണ്ടിരിക്കുന്നു.
Sorry.
Yeah, just check if you can connect that host. The MySQL. I mean, you mentioned the host as MySQL WordPress MySQL, right? Just do a
Correct.
curl.
Yeah.
Yeah,
Sorry.
even curl is fine. Curl WordPress
Um,
MySQL colon port. Yeah,
sorry.
curl. Yeah, see, just put a curl and then give the host as WordPress hyphen MySQL colon the port of MySQL, which is 3306. Yeah. Yeah, so this is where it is. I mean, so this should have at least given you something. So can you just go out of this and say OC, sorry, kubectl get EP endpoints just to see if the labeling was gone wrong. Kubectl get EP. Yeah. Yeah. So okay, just put that namespace. Sorry.
Yeah.
Okay. So, the WordPress MySQL endpoint is two. So just check whether this. So this is the IP of your pod. Any difference? OC get pods.
Right.
Yeah. 2204991. Yeah.
This one.
Sorry. Yeah. Okay. It's where is it?
Yeah, this is good.
115. Okay. WordPress app is 115. The
Hmm.
database is 114. Okay. Now the only thing is that you have to check for DB passwords are all correct.
Maybe the password I correct. I might screw up something here because last yesterday I some did something. Let me check that. Okay. We'll check this. Password is WordPress
Do you have
user.
do you have the MySQL binaries within the WordPress app? You can
Let
just
me
log
check.
in.
There should be. Let me check this first. Confirm this first. Database
Okay.
is WordPress. Database is WordPress. Uh, I think something I alright. DB host, DB user. I didn't mention the DB. I think I overwrite something here. Yeah, that's the issue. Let me check the alt commit. Sorry for that. WordPress DB name. I missed that. Yes, 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 yes. I have override something last day with this.
Ganesh, there is a typo in your key.
Oh,
That's
thank you, thank you, thank you. Okay, we'll create from scratch. Sorry for that. I was doing some kind of thing for another demo. I think I overwrite something here. Same again.
No, no, I think the web page was waiting for it to load.
Okay, maybe. I should have created another repository for the R&D, sorry. Mhm.
Hello, Janish. Hello.
Yes,
Okay, I have tried this before. In my case, it was about the DB connections that I have to create the WordPress manually inside the kubectl. I don't know what happened, but that worked. And also, you will get a clear error logs in if you try to access WP admin.
sorry again.
Can you check the URL WP admin using the same WordPress post? It will it will give you a clear idea about the connection issue.
WP admin. Okay,
Yeah,
let me
yeah, yeah.
try. Because I didn't configure it yet. So maybe I can hide this as
Now
well.
it
This WP admin. Actually, I was trying to configure something, but then I don't know where I.
actually it's actually we don't have to deploy the configure the WP admin, but the URL will show something related to the connection. Uh, if you try.
Okay, 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 we'll try. I'm just,
Okay.
I'll wait for that.
Okay.
Yeah, I was trying trying something last day for another demonstration. Then I forget. Okay, I'm using the same repo for this today. I forgot to take a copy.
It's
I
okay. It's
forgot
okay.
what
It's
I was
okay.
doing.
So
I
far
forgot
it's good.
actually.
So far it's good.
Oh, sorry. Oh my God.
Can we connect to the MySQL pod and check whether the credentials are working there locally, or check whether the WordPress DB is created there or not?
Oh yeah, can actually. Anyone else facing the same error or?
I actually I have heard this before. I'm not actually deploying it right now because I'm using a Kubernetes cluster, not the minikube. So I have stuck with the hey part. So I just watching this video.
Okay, okay. Yeah. And it was running. I put everything here. I thought I should not test that, but somehow I tested.
Yeah,
And then
it's
I
okay. It's okay.
threw
It's
up.
okay. Maybe you can try to connect to the MySQL part from. Yeah, that's it.
My SQL username is
Maybe it's root, I think.
actually
Okay,
we
there's
put
a custom
something
username,
here.
right? Okay, okay.
Password user is sorry. Um,
Minus P.
hmm, that's my bad. Okay, we have this.
Yeah, show databases will
Still
show
still
the.
showing this, right?
Show. Can you check the show databases?
We
Yeah,
have the
it's there.
database.
It's there. Yeah, WordPress DB is there. I think it's about the host part. I think.
Maybe some connection,
Yeah.
not user. Okay.
Yeah, so basically from the WordPress app, you should be able to connect to the MySQL pod, right? So I
Yeah.
mean, so I think our first curl was not working. So the curl host name colon port, right? Can you
Correct.
just go to your host once again? That pod once again. WordPress.
Yeah, there's a two port. I don't know why it's a two port.
Let's go into that pod once.
In my case, it worked when I applied the endpoint that's the IP address in the deployment part of the WordPress, the host part.
So then it means that the DNS is not working.
Yeah.
So just do a curl minus v, yeah, and the host name,
In WordPress MySQL.
yeah, MySQL, yeah, MySQL colon 3306. Yeah, yeah.
Hmm.
So this should resolve. So
Yeah, correct.
just change this to the IP
All right.
or IP.
Port IP. Okay.
Or okay, even you can use the service IP as well. Yeah, no problem.
Correct. This is strange. No.
But the thing is, okay, so there is a DNS issue for sure. Okay,
Hmm. Hmm.
right. So now the other part is it's not able to send. So the pod to pod is not working.
Correct.
So did you do anything with firewall or anything?
Actually, yes.
Actually,
Not one.
it's
Not
not
that.
because it is on the same bridge, so it should not.
Uh,
Yeah, I mean, yeah, that's fine, Ganesh. I think we could conclude with saying like what you expect and what you were supposed to
yeah.
show us. Like
Yeah.
that's fine.
It's okay. We
Yes, yes,
can
yes.
recreate it anyway.
Yeah.
I don't know. I was using the same cluster, so maybe we can just recreate it. Let me try. Okay, we will take some questions and all. We'll see how. I mean, anyway, the YAML I need to fix and see.
Okay.
I want to check whether it's a cluster issue or it's like a YAML issue facing anyone else.
Yeah. So one of our audience forum, it worked after changing the host name and the service name to the pod IP, and it worked for them.
Okay,
Uh,
then my yeah,
yeah, yeah. I mean, I'm just saying. I mean, I don't know. I'm just saying. But anyway, that's fine. Yeah, this is bound to happen, but that's fine. So anything. So we could conclude with what you wanted to show us and what you wanted to explain to us in terms of this app in case. Yeah.
correct. Yeah, you can test it anyway. I forget. Okay, we can take some. I mean, Any other questions or something?
Yeah, any questions for Girish
Uh,
in terms of scaling or anything? Yeah, please go
yeah,
ahead.
hello, Jinish. Nice to meet you. And the presentation was good. This happens. It's okay. Uh, I have this doubt.
Sorry for
Okay, I have this doubt.
yeah.
In Docker, we have, if the Docker containers are in the same network, we can mention it like they're using their names, right? Uh,
Yeah.
if we have two Docker containers like the name WordPress and MySQL, so we can mention uh, the MySQL host as just in WordPress using just the MySQL, the name of that port. Will this in Kubernetes it work the same, or we have to mention the port? Oh, sorry, mention the IP address or something else to connect to that host. I think,
No, you mean the connection
yeah,
between
yeah.
the ports, right?
Between the ports using the name of the port. Is it possible
No, we
if it's in the same namespace?
even if it's a namespace, we should use the service
Or
because
service name?
yeah,
Okay,
because
okay,
the
okay,
port can be recreated anytime, right? We have no control on
okay,
that.
okay, okay. So
So
we
whenever
we
they say every time the port and the IP address will change. So that's
okay.
where we use the service object. So we always
Oh,
talk to the
okay,
service. It's like it's a load balancer. So it will
okay,
we just always talk to this guy. He will talk to the backend guys one or more ports.
okay. We can use the service name. Okay, okay.
Yeah. Let me try this time.
I have one more question.
Yeah, please.
Uh, can you just I have this doubt that what is the purpose of PV and PVC here in this WordPress scenario? Can you just explain?
PV and PVC.
Yeah.
Okay, PV is basically okay. When you have a stateful application, like if you want to store something, right?
Yeah.
You have you should have a storage in the backend. So basically, in Kubernetes, you have resource called PVC and PV. Basically, they are all connected. So in all time, I mean, few years ago, before the dynamic storage was introduced, you have to create the PV and assign or make it available for the PVC to automatically mount. So let's say my application need like a 5 GB storage. So I don't have a control on the storage part because storage is like infra, it's a global one, right? You don't have a cluster kind of access to do that kind of thing. So what you do, you create a PVC a requirement. Okay, I need to use 5 GB of or 10 GB or 100 GB as a PVC resource. So what will happen in the backend? If I mean earlier it will check for the available PV and mount it, but now we have the CSI or the storage class, all the stuff and dynamic provisioning. When you have a PVC, the storage class, if it matches, actually you have some parameters here. So if you check here, there is one parameter called access mode, rewrite many or rewrite once, depends on the parameter and depends on the storage class matches. It will create the backend storage for you. That's called we call the PV. So let's say if it's a VMware, you are talking to the storage class, which is like a VMware one. Then in the backend VMware, inside the VMware, it will create the disk for you. If it's a GCP or AWS or something, yeah. But whatever the storage class you configured, the storage or the disk will be created based on your PVC. So you or developer only need to mention the PVC, the claim required for the application or the database, and the backend will automatically operate it to provision the PV. Is that clear?
Okay, so the data in the PV part will remain the same unless we deleted it manually, right?
Not really. Actually, you have more options here. You can mention whether the PV, the storage should be retained or
Okay, okay,
recycled. There are some options. If you
okay,
check
fine, fine.
here, let me see if I can find. No, I think we lost that.
Okay, no problem.
You will see that. Yeah.
Okay, okay. I have one more thing. I don't know. It's a beginner level one. Actually, when a PVC is created or PV is created, it's actually created on some one of the node, right? Under one of the
Okay.
hello.
You're talking about Minikube.
Not about the Minikube. If we have a master node cluster, If we create a PV or PVC, it's actually created under one of the node, right?
No, no, no. So depends
No.
on the class again. No,
Okay.
PV, yeah, if your PV or the storage class is like a VMware I mentioned, right? Actually, the disk is created outside in the actual storage. It can be any storage, can be your actual HP storage, it can be your Hitachi storage, it can be any storage which is outside of your cluster, but it's
Okay. Okay.
connected using
But
the storage operator. Yeah,
Yeah, can you
okay.
just make it easy,
yeah,
just to make it easy, right? Just look at the storage as an NFS share.
Yeah.
correct.
Okay.
Okay.
Just look at it as an NFS share. So if you want multiple pods to access the same share, you would
Okay.
look at the storage class which should allow you to access multi-access, right? So if
Okay.
you're since you mentioned about master, I think what happens there is you're using something called as host path, right? So
Okay.
that PV is specifically for that node only. So let's say, for example, if the pod runs on a different worker node, so that path is not available. So what you need to do is you need to plan according to your needs. That is, what sort of storage you need. That is single access. That is read write once. I mean, like Ginesh is showing you. So there is something. The access modes are like read write once, read write many. So read write once means only one pod can access
Okay.
that's to maintain the file system integrity, right? Because if two processes touch the same file system, then it can be a problem. So even if you have to choose what sort of file system you need to have on top of those shared storage, right? So
Okay.
those are things you need to plan. But as Ginesh said, it can be any storage. So it
Hello. Hello. I can't hear you. Hello.
I think got dropped.
Oh yeah. I think I can. Some connection issue might.
okay.
Okay.
So
Yeah,
is your answer?
now I can hear. Yeah.
Yeah. Yeah. There is a connection. I can't hear you. Oh.
I mean, so up to what do you hear? I mean, should we start from the beginning, or should we?
There was a break actually in between.
Action. Yes. Yes.
Okay, so I mean, just to repeat, right? So your question was, you had something on the master node, right? I mean, you were saying that the persistent volume was on the master node and how to access on the pod, right? I mean,
Yeah.
so that was the question. So I mean, as I said before, you need to just look at the storage as a separate entity outside of your Kubernetes cluster,
Yeah.
right?
Okay. Okay.
Storage shouldn't be part of the Kubernetes cluster. I mean, that is the best practice how you design. But in case if you're running into, if you don't have such a huge resources, then you can look at having an enough a share configured on one of the node. So that will make your life more complex. But but you have to make sure that the storage is outside of the Kubernetes cluster because the data is more important than the cluster because the cluster can go down any point.
Yes. Yes.
You can
Yes.
use the same
Yeah.
storage and access on a different pod. So
Okay. That.
yeah, okay, thank you. Yeah.
Okay. Okay. I get it. It's a good practice. I got it. I got it. I got it. Thank you. Thank you so much. Hello.
Yes.
Okay. Okay. That's it. That's it, Dinesh.
Okay.
Any other questions?
Hello,
Yeah,
hello.
go ahead.
Can you hear me? Yeah, hi.
Yeah.
Yeah, this is Uma. So actually, I'm beginner to this Kubernetes, but theoretically I know, but practically I have to do hands-on more. So actually, basically, no Kubernetes will have master node and worker node, right? So here you provision for servers, deployment instances, right? So in this, which is master node, which is worker node?
You mean in actual Kubernetes cluster, right?
Yeah, asking about the Kubernetes cluster.
Yeah. What is the question again?
Actually, which is the master node here and which is the worker node here?
Okay. So yeah, basically, this one is our test environment. We have only one node.
Okay.
Okay. So here, the same node will act as control plane and worker node. We are not doing that node level assignment. It's just like a local setup. I just recreated the cluster. You can see, right? Deleted the cluster and recreated because it's a Kube1 dev environment. You can do the same for like testing, quickly testing with the latest version or different versions and all. You can try with Minikube with the multi-node. There is an option, but if for the multi-node testing, highly recommended to use with different setup like kind. You can use the kind cluster with with like a multiple nodes, like multiple master nodes or compute nodes and control nodes. Everything can be configured. In our case, we don't have that.
Okay, okay.
That's why I mentioned, okay, it depends on your cluster you are using. You can see the controller node and compute nodes. Usually the worker, or I call it compute nodes, the
Okay.
workload will be assigned to the worker nodes or the compute nodes, not on the master nodes. So in our
Okay.
case, we don't have that. That's why you are not able to see
Uh,
that. Yeah.
okay, okay. Got it now.
Yeah.
Thank you.
Thank you. Yeah. This one I screw up somewhere. Sorry for that. I will fix and update the repository later. You can use it. Please bookmark it. I will update it. It was perfectly working.
Actually, Ganesh, thank you so much. It was very
Sure.
informative and really, thank you.
Thank you. Thank you. Thank you.
Yeah, just Girish, just wanted to answer that previous question from Uma. Like,
Yeah,
how
please.
do you, I mean, in this cluster, so this is what we call as a single node cluster. I mean, imagine in that way, right? I mean, typically when you deploy a Kubernetes cluster, you have a control plane, you have a data plane, right? So this is just, as Girish rightly said, this is just for us to get started with, quickly test your deployment, see everything is working before you deploy onto a multi-node cluster environment. So only on a multi-node cluster environment where you would see, master nodes and the worker nodes, right? So in case if you have a multi-node environment, right? If you see kubectl get nodes, right? It will list which node is the control plane and which node is the worker node. So you can easily identify them. And here it is a single node, so you don't have, yeah, but in this also you would have the master components running on the same node, right? Because the Kubernetes cluster has several master components like the API server, HCD, the control manager, the scheduler, right? So these are called as the control planes. And on the data plane, you have the kubelet. So when you have a single node cluster, you have all these components running on the same server. Does it answer your question, or you want further, anything further?
Yeah, thank you. Thank you. I understood now.
Okay.
So can we see the components in CLI also of the control master node for worker node?
Yes. So, Girish, do you have a multi-cluster, multi-node cluster with you right now?
Yeah, I can create one now.
Or even you log into the Minikube, right? You could show us
Yeah.
the
Yeah,
show us
Minikube
the
actually you can see that
minutes.
what are the components available. So usually, let me start the Minikube again. Basically, you can see the components like the API, the metrics. I think I show earlier, but let me explain that. You can show that components. You can see that components running on the same node in our case.
Okay.
It's opening. Give me a second. Okay, so in our cluster, kubectl get for example ports. I'm just getting all the ports. So if you get Y, you can see the components. Now it's all running on the same node, Minikube. Let me show it here. So you can see different components for the kube system. So it's a etcd, kube API server, controller manager, proxy, kube scheduler, everything can be seen.
Yeah.
So the main point here is that it is not running as a process. It is running, I mean, when I say process, it is still a process. It is not running as a daemon. It is running as application within a container itself, right? So,
Yes, correct.
so that is the, uh, that, I mean, you could also still have, I mean, maybe you could still have the processes running on the host system itself as a common daemon. But, when, I mean, in the newer versions, we have every master components and every host components also as running as a container itself. So here
Correct.
you see under the kube system, you have the pod running, right? So the master component is running as a pod or as a container.
Yeah, that's correct.
So all the
See,
components are running in one single container, single pod in a master node, right?
not exactly. So if you see, the command that is typed by Dinesh, it is kubectl get pods, right?
Ah,
So, so if it is a single container, I mean, if it is a single pod, then you would see only one pod name. But you can see that you can see multiple pod names. So each process is running as a separate pod. So within that pod, you could have multiple containers. But how do you see that? So you can see that 1-1. So that means there is one container in the pod. So in a pod, you only have a single container running.
so I can say that so all these components are running as a container in a single pod, right?
Yes. Yeah.
Okay.
If you want to see, I mean, Girish, if you're okay, I can share my screen.
Sure, sure, please.
Yeah. Okay, just to it is not a vanilla Kubernetes. It is OpenShift, right? So just don't mind about it. Let me see if I can share if everything is good. Don't know. Can you see my screen? Anyone? No? Yes? No?
No.
Not yet.
Okay. Okay, I think I'm from a different. I'm trying to access from a different system. So anyway, that's fine. So I will try to paste it in the chat and then I will explain. Okay, just a second. I don't want to waste your time, so I'll just quickly share it in the chat and explain. Okay.
Okay.
So if you see here, right, I'm just going to paste it on the chat. Where's the chat? All right. So this is from a Kubernetes cluster. Can you make the chat bigger, right, so that you can see that? So just click on top where you can make the chat window bigger, right? Right. Yeah. So Ginish, can you just copy it to your WordPad, this
Yeah,
output,
sure.
and share the screen? Yeah.
Copy these. Okay. Actually, I need to break it.
No. Just open just open a notepad, right? I mean a KWrite or the gedit, and just and bring it to the screen. Yeah. Open a gedit. Yeah. Just paste it here.
I think it's
Okay.
a multi-line. I have to split it. Where is it? Might be. It's a
Let
single line, so we have to split it, I think.
Okay, let me fix it. Okay.
Question.
Okay, so Uma, if you can just see the chat, I think it will take more time to split. So each line, right? The IP, if you see the line starts with IP, so that's a node, right? So here, if you see, there is I mean, the control plane. Do you see a text called as control plane, comma master?
Yeah.
So that node is classified as a master node, right? So it is easy for you to identify what role each node is playing on a multi-node cluster, right?
Okay.
So if you see the other one, right, the worker node, you will see it as compute.
Yeah.
So that means it is a worker node. So the other node which you see as a control plane comma master, that we call as the master node or the control plane node, right?
Yeah, okay.
Okay, so this is how you identify. So it means that all the master plane components do run on the master node, and all the Kubernetes worker node components, they run on the worker node. So you should go through the not the docs to. I mean, I know you do, but to understand which are the master node components and which are the worker node components.
Okay, got it.
Okay.
Yeah, thank you.
No problem. Yeah. Any other questions for Ganesh? Okay, I guess we are good then, Ganesh. If you want to have a last word for the audience, Ganesh.
Yeah, sure. Sorry for that mess up. Sorry, I will fix that, and it will be good in repository later today. Thank you for joining. Thanks for the interaction. It was like I didn't feel like it's a workshop. It was like a more interactive way. I think we learned a lot. If you have any questions, please reach out. Anyone in the call, or you can contact via other message options. Yeah, that's it. Thank you so much.
Yeah, so thank you all. So I would just like to inform you all that the next week, Saturday, we have the next webinar, which is a free one, and it is going to be on Kubernetes monitoring using Elastic Stack, right? I would recommend that you all join and learn more about monitoring using Elastic Stack. So we have a speaker joining us from New Zealand, and he will guide us through through the best practices in and outs of monitoring using Elastic Stack. Right. So see you next week, and thank you all for joining. And in case if you have any follow-up questions, you could ask on the Kerala KCD WhatsApp group. I will see Ganesh will answer to it, or I will also help him with it. Yeah.
Sure. Yeah, you can also, I think the slide I will share later in the same link, the same workshop page, so you can access from the.
Okay, guys. So thanks a lot. So see you next week, and keep in mind our KCD event is on 3rd of Feb. Right. See you all there in person. Yeah.
Thank you all.
Bye bye.